Welcome, finally, to Inside Laravel. Today we're covering queues, the bus, and jobs. I'm pretty excited about this one, honestly. I've spent a lot of time inside of the queues. I wrote a queue driver both for Google PubSub and for Google Cloud Task, the latter being a much better option. And I think the background jobs are a really important part of the PHP ecosystem in terms of enabling us to do things that we can't do without them. And I think that Laravel's implementation in particular is quite good. So I'm going to attack this kind of the way that I have most of the subjects we've covered to date, which is starting from the sort of front end, if you will, where as Laravel users we would typically interact with it, and then I'll dig down. So I'm going to start with dispatch sync because that's a lot simpler than dispatch. I also want to dig into dispatch after request, is it? Because that did not work the way that I expected it to, and I hope others are not making the same mistake. So all right, so we're going to dig into dispatch sync. So I have a test job. This was created last time, and basically takes a user as the single argument. That's it. Doesn't do anything. So I'm going to call it here in my profile controller and call dispatch sync on it. So dispatch sync ultimately resolves to the dispatchable. And excuse me, where this is the trait that we implement right here. Right, so this is standard Laravel jobs. It has the dispatchable trait. So dispatch sync will create an instance of the dispatcher class. Or it's an interface, so a class that implements the dispatcher class. And sorry, I lost. There we go. Call dispatch sync on it, and what it will pass into that is just an instance of the object that is implementing this trait, right? So new static being in this case test job, and it will just splat the arguments into it that were passed into dispatch sync. So in this case, that's going to be the user, right? So let's jump into this dispatch sync method. So this is the interface, and the implementation, there's two of them, either the bus dispatcher or the fake. So this is how the bus fake works when you call bus : fake within your tests. It just switches out the underlying implementation for one or the other. So obviously we're going to be in the real dispatcher. And then inside of here, we're going to check and see if it is a queuable job. And if so, dispatch it to the queue, which is on the sync connection, or it's going to be dispatched using dispatch now. So essentially, if we have a queue resolver, which is what allows us to figure out what queues are available to us, and the command should be queued, which just checks that it's an instance of should queue. So you'll see right here, should queue. Going back to, here. And the method onConnection exists, which it must exist if it implements queuable, which it should. So if we look here, onConnection exists. Then it will return this dispatch to queue, the command calling onConnection passing in sync. So I guess the value here is that maybe you have a queue system that allows you to run commands synchronously, but not within the same process as PHP itself, right? So The value there is that you can offload the resources for that job, maybe to or offload it to just some other system. So it could be calling, an API that runs Go or something, right? It allows you to shove it somewhere else outside of the current process, but you're still waiting for it, right? So that's actually pretty nice. Otherwise, it will call dispatch now. So we're going to dig into dispatch now because it's a little simpler. So this, the first thing this does is it calls class use recursive on the command, which is our test job instance. And then it does this in array to check if interact with queue or queuable are used. And what I've mentioned previously is that this is actually bad code. I'm going to put a comment in here. Class uses recursive returns an array that is both keyed and valued with the trait names, class names, trait names, which means that rather than doing an expensive in array, which is going to iterate until it finds the value, it can just do an isSet, which is just an O1 key lookup, right? And if the job is not set, then it will set the job. So I believe that this is used when you have like retries. It wouldn't retry to set the job. So it's going to create a new sync job, which makes sense. It's going to pass in the container, which is the service container. JSON encode an array. What is that argument? Which is the payload. And then set the connection name in the queue to sync. I don't know why this is happening. I don't know if it's going to get overridden or what. Ultimately, yeah, this is just managing retries for the most part. Then if the handler is null, which it always is in dispatch sync, I just want to show that. Dispatchable. I guess it depends how you call it. No, that's not correct. Dispatch sync, sorry, is being called in here. Yeah. Okay, so yes, when calling dispatch sync on the object yourself, like if you're implementing dispatchable, it only ever passes in one argument. So ultimately, we don't need to follow that branch of the code. So if falsy or assign it using the get command handler, not a huge fan of that pattern, but using it more now. I'm using JavaScript. If has command handler this get class command this handlers. Okay, I do not know what handlers are. I have not yet looked into that. I'm not going to get too distracted by it. Non-self-handling events. I didn't know you could do that. Huh. I think one benefit there is that you could have a whole bunch of this is used for events. Huh. We'll get back to that. I don't want to get sidetracked. Because we clearly already have. Okay, so dispatch sync, dispatch now. Okay. So we're going to assume that it doesn't have, that it is self-handling. Which means that we are going to create this closure, passing in the command, check to see if the handle method exists, or use invoke. So there's no way to customize this method here. if you recall from last week when we were looking at something else, what did we look at last week? One of the first things that we looked at, I think it was managers. So it wasn't the first thing, which was the service container. There's a way to set sort of the handler function. You can't do that with jobs. They always use either handle or invoke if they're an invocable class. What I find interesting is that it's not actually going to, like, the whole point of invoke is that, like, you can just do this, right, on the object, and invoke will be called automatically. But there's nothing stopping you from just calling it like this, right? This is essentially the same thing. So I think that is what's going to ultimately end up being here. So then they use container call. So the reason they're doing this, and they're using the container to call it, is it actually goes through dependency injection, right? This is where dependency injection happens. And if you go and look at the Laravel docs for the service container, there is a here app call, which essentially allows you to call any method on, or any callable, really, and dependency inject its arguments. I believe you can add extra arguments. Yes. So if you wanted to set some arguments by hand, you could. Otherwise, and then it would sort of inject after that. Otherwise, everything would have to be injected, right? So that's all that's doing. So I apologize. There's somebody at my door. That exited the wrong house. Fantastic. All right, so apologies. Okay, so it's going to create this callback, and then it is going to. This is interesting. Yes, okay. This is actually great. So this is using pipelines, which we covered earlier, I believe. Yes, we did, in the HTTP request stuff. So what it's going to do is it's going to send the command through the list of pipes, which are the middlewares that you can set up. And then it will call the callback ultimately at the end of it, which I find kind of interesting. That actually isn't the way that I would have expected it to do that. Send command through the pipes then. Because it's sending literally it enables you to modify the jobs to add extra whatever, right? But what I'm not sure is how it would then ultimately do that on the way out, because if I remember correctly, then it's just called. No, it isn't called at the end. Okay, my mistake. Yeah, so that's what's going to happen, is it's going to send the original command, not this kind of wrapped closure.
that executes it through all of the pipes, which are your middlewares. And then this callback is what sort of executes that pipeline. So it goes through the middleware in, runs the callback, and then ultimately comes back out, back through your middlewares. So yeah, very similar to HTTP middleware, as I mentioned before in that stream. All sort of middleware is implemented using pipelines, and it's a really cool concept. So that is what is happening here. So when you run a job synchronously, it still goes through all of the middleware, which is cool. It can be queuable, which means that it can be synchronously executed on an external queue as opposed to locally. And it can even be handled by an alternative handler. All of these features sort of encapsulated in a very small amount of code, honestly, which is really, really cool. So that is dispatch now. Obviously, we haven't really looked into queues yet, and all non-synchronous jobs will run through a queue. I do feel like so if it's not marked as should be queued, but does use these two traits, is the only time we would ever get here, which I feel like is a very uncommon way to set up jobs, which makes this in array even more egregious, to be honest. This should be as fast as possible, considering it's almost always going to fail. Or rather, we're never going to get here. Maybe it doesn't matter then, because we're always going to end up here. All right, so I'm not going to jump into this because, as I said, ultimately, I believe the regular dispatches will end up here. So we'll end up going through the queues and the queue resolvers next anyways. All right, let's go back to our profile controller, and we'll do dispatch, just dispatch, okay. So, as I mentioned when I was muted, is rather than executing the code, what it will do is just create an instance of pending dispatch and pass in a new instance of the job class and splat the argument. So very similar to dispatch sync down here where it does this and passes in a new instance. It's doing the same thing up here. But in this case, it's just returning an instance of pending dispatch. And that is why when you add a doc block to your job so that you can autocomplete it. For the dispatch one, you want to have pending dispatch. For I think it's void actually. For dispatch sync, you're going to want to use void. Certainly, it's not pending dispatch, right? Because that isn't what gets called. Actually, I'm curious. Let's see what that return actually is. It returns dispatch sync, which returns mixed, which returns dispatch now. I think this is going to ultimately return the command. I think that's ultimately what ends up happening, right? Because you've got then and then return. Let me just quickly look at the. I don't remember if there's docs on this. This is one of the things that isn't documented. Pipelines. Nope, they are. Then return. I guess not. Different kind of pipeline. Hold on. Yes. Okay. So what does then? As you can see here, what does then return? Typically, this callable will simply return a given input. Yeah. So, which is the job. So that is my expectation then, is that when running a synchronous job, what you will actually get back is an instance of static or self or whatever you want to call it, right? Um, which is fine. Uh, it does mean that you could, of course, dispatch sync. You could, of course, then access properties or something on it, right? So that's actually, I guess, not the worst thing in the world, right? So, but you could also it does mean that whatever the handle method returns doesn't actually get returned, though, I don't believe. Why don't we test that? Let's test that. Return foo. Well, string. Okay. I think that I have. No, I don't think so. Okay. App jobs, test job, dispatch, sync, user, make. I don't know if that will work. Didn't think so. Method exists. Argument must be what? I think it's because I made changes. Hold on. Dispatcher. This one. What line was it? 229? I did not make those changes. Yeah, I generally don't know why that is calling that way. It might be because of my config. Because as far as I can tell, 229 we know where we're there. All right, let's take out should queue and try that again. Yeah, we do get foo back. Okay, so that's interesting to know. Manchuck says, I miss PHP. TypeScript world drives me crazy. I have been spending a lot of time in TypeScript. I am not a fan of the syntax, but I do like the safety that it brings, is all I'll say about that. And the syntax is just uncomfortable right now. I just haven't used it enough. All right, so that is confirmed. If you call dispatch sync, then the value that your handle method returns will be returned. So that could be useful, right? I think I wouldn't. Ultimately, if you're building a job to do that and you have that expectation, it's always intended to be synchronous, I think is the way to think about that. And I just don't know that that's a valuable thing to do. I do think it's valuable that you can call jobs synchronously that would normally be asynchronously. So I'm not saying that dispatch sync is a bad thing to do. But I absolutely am saying that if you are building jobs that return values, and the expectation is you're going to use it, then it probably should be abstracted somewhere else, and the job should call whatever that thing is, whether that's a service or an action or something like that, right? All right, let's dig finally into dispatch and actually dig into pending dispatch, which we already know is what's going to get returned. So, pending dispatch is an object that allows us to set all of the job sort of settings. So, allows us to change the connection, the queue. It also allows us to set the delay or without delay, and then allows us to run after commit. So when all database transactions have been committed, or before, I've seen that before, or set up job chains. Let's see, set the jobs that should run. Yeah, so you can add additional jobs that will only execute if this one is successful. Now see, I believe that dispatch after response and dispatch and then after response, to be clear, that this and this are going to execute differently. And we'll get to that later. Okay, so let's remove this one because we're still digging into here. Into pending dispatch. There is what I'm trying to show you here. I also didn't realize that you can proxy methods through to the original job. So in theory, you could, I don't know, run something here, like, handle even. Right? That would be dumb, but you could do it. All right, so getting back to our pending dispatch, what I'm looking for is where this ultimately gets executed, and it's right here. So I think I was incorrect about dispatch after response and the after response call, and maybe this is new. One of the things I really wish Laravel did is that it added version numbers to its doc blocks. See you later, Chuck. All right, so the way that the queue gets executed is on destruct. So destructors are called during, well, I guess multiple times. If the instance is destroyed and there are no more references to it, then destruct is called. For something like this, where it is never intentionally destroyed, it is going to execute at the end of the request when it winds down the whole request, right? And so, assuming that it is dispatchable and it's not set to after response, it's going to call the dispatch method on the dispatcher class, which is over here somewhere. Yep. Okay. So where is our dispatch method? Right here. And ultimately, it does two things. It either dispatches it to the queue if it should be queued, and we have a queue resolver, or it dispatches now. And if I remember correctly, this is ultimately where we were going. So it's going to run synchronously, and I think that's an important thing to know, is that if your config is broken, then what was a synchronous request could end up being, what was an asynchronous request could end up being synchronous, right? But let's assume everything's set up correctly. This is where it will call dispatch to queue, and it will set the connection from the command if it's there. Then it will call queue resolver connection, Right, so queue resolver is what? Where does that even get set? Here, this doesn't help us. I think it's going to be here. Yes, here's our queue dispatch, our queue resolver. So it gets the queue factory and calls connection on that with connection that's passed in. Where were we now? Dispatch to queue. Yeah, so it's kind of an interesting, I don't know why it isn't just that. Well, sorry, it would have to be that, right? That is also something that could be optimized. His call user func is also quite heavy for what it is. All right, so we'll call the queue resolver, which ultimately is going to figure out which queue to call from your config. If the queue is not an instance of queue, then it couldn't resolve it. Otherwise, if the command has a queue function on it, then it will call queue passing in the queue and the command, which is this. Not sure why it would pass that in, but okay. And then it pushes the command to the queue. Right, this is the thing that we actually care about. So if the command queue is set and there is a delay, which I love using is set this way, return queue later on, we'll look at that later. If the queue is set only and it's not delayed, we'll just push it on. Or if the queue is not set but there is a delay, then we'll just call it later. So this later on is not, oh, I'll do that later on. It's later on a specific queue. So that naming is a little bit desired. If it is neither has a queue set or is delayed, then it will just push it to the queue. So I think what's interesting there is that while this is ultimately where you can override the queue that it gets sent to, right? And it's not, I don't think, entirely clear. So this queue resolver is going to get the queue, the default queue that is set up for all jobs, right? And ultimately, here, or here, either way, if there is a queue defined in the job, then it is going to send it on that queue instead. Otherwise, it's going to add it to the default queue, right? So these two go to the queue that is defined in the job. These two go to the default queue that was found based on your config. Ultimately, though, I think these are just going to resolve to the same kind of thing. So let's, what was that? Command Shift Y, something like that. Command Y. There we go. Oh, it's just a contract. That is annoying. Okay, well, let's take a look at this here later. Sorry. Sorry, does this just take... It does. I feel like this could be optimized as well. Like, there's so many layers of indirection happening here. In the, like, let's just look at this one instead. It's just calling push with the queue. Like, it just reorders the arguments. Like, it's not doing really anything at all. Like, that here, this could just as easily be, I guess what's data? It's an empty string, right? So it has a, you could literally just do, or, I mean, heck, you could just do this. Like, if this is null, which it would resolve to if it's not set, I guess there's an opportunity there for a notice. So yeah, I would just do that just to avoid the notice. I'm pretty sure that it defaults to null anyways. There's no reason not to do this and get rid of all of this. I will probably clean a lot of this stuff up and throw a PR in. Okay, so we are only going to look at later and push because ultimately these resolve to that anyways. We can all agree with that. So let's look at push first, the simplest one, presumably. And this ultimately now resolves to a specific queue, right? And this is how it gets like determined what that message looks like, right? So in the case of Redis, it's going to queue using, which is an internal function, right, inside of Redis. We don't actually care what that does, honestly. Mainly what matters here is create payload. Let me just double check here. What is happening with like callback? And this is mostly just sending out events. Oh, this is used everywhere. At least most drivers. Okay. Yeah, so basically it's these are just kind of the datas that get put into the job, like the job itself, its payload, the queue that it's executing on, any delay. And then this is where the actual like magic happens of pushing it into the queue. And so push raw, can I go back to that current method? Here, right? I'm not going to go into that. I want to look at the create payload first. So this is how like the content of the job gets encoded. It is also where the magic around closures happens because you can't serialize a closure, I believe, or there are cases where you can't serialize a closure, right? Serialize function. Yeah, see? I have no idea how that works. We're going to dig into that. So it's going to create this JSON encoded payload. And I believe so this is where encryption happens. But ultimately, this is the actual payload that gets sent to all of the queues. So when you send a job to the queue, it doesn't just like serialize the object and send that. It sends a whole like envelope with that serialized object being a part of it. And so that includes a UUID, the display name. So you can actually, what is this? Get display name. What does it do? Yeah, you can define a display name method on your job. And I think that might show up in Horizon. Um, maybe it's using other drivers as well. I'm not sure. Um, the job itself, I'm not sure why that is hard coded to that. The max number of tries, the max number of like all of these configuration options, right, that you set on a job. This is where they happen. Notably missing, I think, is delay. And then in here, this is where your like job itself lives. Find it curious that these are the same value. And then there's the with create payload hooks. I think this is where the model serialization happens. Let's see. I don't see it in here. I'm just gonna implement it. Oh, yeah, it's here. Oh, it overrides serialized. That's all that's happening. So that is going to get called when the object is serialized. So, okay. Go back to where we were, which was here. Okay. So I'm curious what the create payload hooks is for. Maybe that is like a driver specific thing. Let's figure it out. Create payload using. What is that? It's part of the log context stuff. I'm not sure. What that's for, but I want to dig into logs, so we're not going to look at that anymore. And then this is life cycle, like test stuff. So I don't think that's the way to go. So what about this one? Yeah, we're basically where we were. So I'm not sure what you would use those for. I wonder if that's an interesting way to add like some metadata as opposed to middleware. I would definitely stick to middleware, frankly. But yeah, this is how the payload gets created. And then if we go back to the Redis queue here, ultimately, it enqueues it using, so whatever the payload gets created and all this stuff here, it's going to push it to Redis here. So this callback is where we actually push that payload through. Um, huh. What is happening here? I don't think I've ever seen this Lua scripts thing before. So these are Redis Lua scripts, which I didn't know was a thing. So we learned something today. And push the job onto the queue. So it calls rpush, push a notification. Okay, so it does both at the same time. I mean, within the same call. Not sure why that's necessary, if I'm being honest. Maybe these aren't exposed via the extension? Wonder if that's like a difference between Redis and Redis, and one has it, one doesn't, and that's the only way to kind of really do that. Having said that, yeah. So this is just going to return that script, right? And then it evals it here. Let's go back to here. And it's setting two keys. The first one, I presume, called getQ, and the second one called getQNotify, and then passing in the payload. I don't know why it's getting the ID back here. Is that going to get set in some way? I don't see it. I don't know why it's doing that. Like presumably that is that payload. It is a string here. Yeah, I think it just needs to. It's kind of janky. Like going back to here, right? Oh, I guess the ID is never returned. It's created inside of the create payload. Here, where was it? Here, right? Oh wait, that's not UID. Where's ID created? Because that's what it was, right? Yeah, it returns the ID. Where does that get set then? I wonder if that is happening inside of Redis. I need a better mic. Is it too quiet, too loud? Because I have a good mic. It's just I don't know if the settings are good. So I'm also assuming that it's using my my Yeti. It might not be. It's not.
Now we're on the better mic. Thank you. Oh, you know what it was when I came back from the door, and I put the AirPods back in. It switched them to the default mic. Thank you, Mac OS. All right. Getting back to it. So I don't know where this ID comes from. I'll be quite honest. I don't see any. I don't want to follow that any further down. But I think obviously the payload is getting modified here. Well, hang on. Unless this is... No, it's not by reference. So it's got to be passed into here, which means it's got to be set during all of this nonsense. And this is JSON encoded, so it has to happen in here. No. I don't know where that's coming from. Let's move on from there. All right, so we have now pushed it onto the queue. We're in the dispatcher. Let's take a look at later, and we'll see how the delays come into this. We're still going to look at Redis again. So basically the same thing, except it's going to call later raw. And in this case, it adds it to a delayed queue instead, with an available at timestamp. So I'm curious how we get from there. Yeah. There's quite a few places here. But I think it's this one that we care about. Let's find out where this is called. Okay, so all of that we looked at before was on the like sender side of the queue. Where we're kind of getting into now is on the worker side of things. I don't want to dig into that yet. But ultimately, it looks like that's what's happening. I find that really interesting, is that the worker is responsible for, in the case of Redis, actually moving the job from the delayed queue into the regular queue. Not the client or the dispatcher. So that is interesting. And I think you have to remember that like Redis is a little different from, say, an SQS or some other type of queue system, where you can just specify, the intended delay, and it won't be released from the queue until that delay has passed, and it'll just be released with the rest of the jobs. Like that whole mechanism is completely transparent to you. So it is. I think it's a really cool way that they've done that in Redis. Okay. So dispatch. I do want to just kind of finish up here. We went through the dispatch command. One moment. That's the last interruption. Okay, so we've gone through how dispatching works. Last thing I wanted to look at, though, was that dispatch after response. So let's take a look at this one. Yeah, it's just calling dispatch after response. So these are identical. What I didn't realize is the dispatch after response doesn't dispatch to the queue after response. It just dispatches synchronously after the response. At least that is the behavior that I have observed. So if we go to here, we end up in the dispatcher class dispatch after response. So let's take a look at that. Yeah, it's just synchronous. I don't think that is clear from the name. I think it should be called dispatch sync after response. Let's take a look at the queues, I guess. Dispatch. I'm just gonna. Oh, whoopsie. Yeah, so I don't think that this. What I would like to see is, and I think it happens anyways, like intuitively, dispatch, and what I thought dispatch after response was, is that it wouldn't dispatch it to the queue until after the response, right? But because of the way that dispatch works, why can't you just fill my screen? There we go. Because of the way dispatch works, in that it uses the destructor, it's always going to be during that shutdown anyways. So it is always going to happen, like it's going to dispatch to the queue after the response. And I think that is important to understand, is that if you schedule if you dispatch a job, it isn't going to get into your queue until the rest of your application is done executing. And that, by the way, is why running test job dispatch doesn't do anything inside of Tinker. Because the reference isn't lost. And so ultimately, it's not, the destructor isn't called. Now, if you wanted to, you could just call destruct. It's probably the easiest way to do it, honestly. But I believe, if I'm not mistaken, if I quit, it would then run. But like, it only got dispatched to my queue, which I don't know what that's set up as. Queue driver database. So presumably, say on MySQL, I don't know what I have it set up as. Select star from jobs. Yeah, see, it didn't add anything. I don't think it's batches. Job batches. Yeah. Now I'm actually curious if because I hate not being able to just dispatch jobs from the terminal, and I guess I could just do dispatch sync. That would work. But I believe. Oop. Still didn't do it. Yeah, not entirely sure. I just know I've consistently had difficulty running it from Tinker. Like I said, you can always just dispatch sync. That's probably the easiest way to do it. But if you want to test, your queue or whatever, you can't do that from Tinker. I always just set up a route with a closure on it and just call that. Nothing but calling the job. So, all right. So that is dispatch sync. That is dispatch after response and dispatch. And we did look at delays very briefly. We also talked about the pipeline, which is how the job middleware works. So I think the next part is, let's talk about the other side, the worker side of things. So that is a little bit more difficult, I think. we were sort of there in the worker. So queue worker, here we go. This is called from somewhere. Construct. Here we go. Okay. So inside of the queue service provider, there is this register worker which creates a worker instance. And so I think ultimately what happens is when you run a worker, this will have executed and it will pull this instance of the worker class out of the service container, right? I want to find, you know what, we should be able to, it should be in, is it here? I want to find the job, here we go, the work command. Here we go. Okay. Service down for maintenance. Otherwise, listen for events. We listen to failed events, so we can write information to the console as jobs are processed. Okay, that's cool. Get the queue, run the worker. This is the function that I think matters. How did worker get set? It's in the constructor. Yeah, it asks for an instance of worker, so it's going to get injected. That's ultimately where it comes from, right? Is this queue service provider. So that's kind of interesting. If you wanted to, you could register a different worker version. All right, so let's talk about the worker. Mostly what it does is creates a loop, gets whatever the next job is on the queue, and then it runs the job. And inside run job, it is going to call this process function, which where are we going? Yeah, okay. So, the fire method, which got called right here, right? So it checks to see if it calls the before job event, or admits it, sorry, marks it as failed if it has run out of retries. So I find that interesting in that if a job fails, it doesn't mark it as failed in the current attempt. It does it in the next one. But before anything is executed, right? If the job has been deleted, which means it's been removed from the queue in some way, but after it was retrieved, then it will just say it was done. Otherwise, it will actually execute the job and then call the after job event, right? So this fire method will first of all get the payload, right? So it's JSON decoding that body that we created on the other side. Sorry. Payload, here we go. So we'll go look at the Redis version again. Just returns this job, which I find interesting. That is, yeah, it's just the string. So that is literally that payload that was created. In the previous thing that we were looking at. Interestingly, the job is the string, like that JSON encoded string, but I'm pretty sure that it gets decoded here. Like, it literally calls get raw body again. So, at least in the case of Redis, it decodes it twice, which is a little frustrating. Here's why. For some queues, for example, SQS, I believe, does it this way. I could be completely off, but let's just say it does. We'll send headers for things like retries, etc., which means you don't need to decode it. It's not part of the message body necessarily. It probably is already. It probably is in there, but it doesn't have to be. And you can get that information without decoding the payload. So this is how Laravel can support drivers or underlying queue systems that don't necessarily have the feature set that Laravel wants at its baseline, like delays, like retries, like max errors, these kinds of things, right? So pretty neat, but something to consider. I do wish that this didn't have to happen twice. It feels wasteful. But okay, so we're in the Fire event. We grab the payload, which is the string. We're going to parse the payload. So we're going to, sorry, we've already done that? Yeah, we've already parsed the payload. So just JSON decoded it. And then we're going to parse the job name to get the class and the method. And that, if we recall, I didn't look into the closure stuff. I definitely want to get back to that. So anyways, sorry, it will parse the job name. So let's see what this does. Parse callback. Default is fire. Parse the job name into a class and method array. Parse the callback. Is this on the string? It really is. It's part of the default string helper. Huh. So yeah, it just takes that syntax that we saw in the I believe it was in the dispatcher, or it was in the Redis. It wasn't Redis job, Redis queue. That feels like a fool's errand looking for @, but it's the only thing that I recall from here. Oh, actually, it wasn't in here. It was in the create payload function here. That is what the format looks like. So it wraps. Does it wrap the job then in one of these? Is that what happens? Where does that happen? Nope. Okay, carrying on. We were inside of Redis job. No, we were inside here. We just called parse, so we're in Fire. So yes, this is going to return the class and the method, which could be that illuminate queue handler thing, but I believe could also be the job itself. So it will resolve the thing. Maybe it isn't. Maybe it is always that queue handler. Okay, so if that's the case, we know what it's going to be, right? We know it's going to be the fire method, was it? On the call queue handler here. Going back to the... No, it's call, the call method. Right, so right here, this is the method that's going to get called by the here. Okay. So this is going to be, I have too many things open. Okay. I think I might have just closed the one that I wanted. Here. Okay. Okay, we'll get rid of that. So this is going to be call queued handler, and this is going to be call. So it's going to resolve from the service container the call queued handler, and then it's going to call, passing in the job, which this is the abstract class job, and the payload. What is this? Where is this being? Because it's going to be like the Redis job, or the... That's why it wraps it. We did see that. Okay, so this will be the example Redis job, and then the payload is the data. And if we remember back to when we were looking at the where it called that function here, the data is the command, like the serialized version of the command, right? So we're going to look now into the call function here. So it has the job, which is the Redis job, and then the data, which is our job. Set job instance if necessary. Okay, so if it is using the queue, it will call set job instance. I wish that hadn't happened. I keep hitting Command Shift W, which is just closing the things on me. What was it? It was queue. Here we go. So set job instance if necessary. And while doing so, if it can't find the model, okay, so if you send a model with your job, what it will do, what the serializes model trait, rather than send the entire model, it will just send the ID, and then it will refetch it fresh inside of the job, which is probably what you want anyways. You don't want a stale version of that. Now, there are certainly cases where you do want like the original at that time, in which case don't use serializes models. But it's just a way to reduce the size of the job content, which is really important for some queues. Some are size limited to the body content, right? So you don't want to serialize a massive model into it. So that's what's happening here, is that when this is being executed, it's rehydrating those models, and if they're not found, well, then it's going to error. This is unique jobs, so ensuring that it does work, and then dispatch through middleware. Cool. Okay, if you try to restore a class and the class cannot be resolved anymore, it will turn into the special object, this double underscore PHP incomplete class. That might happen if you roll out a new release and refactor some stuff and you have old jobs that are still in your queue. I don't really see any other reason that would happen in any sane environment, but I think it's worthwhile noting that it does do that. And then it creates a pipeline. So this is the same pipeline. Slightly different pipeline. So actually I think that is also important to see. So going back to dispatchable, we'll just go into here. Wait, here is what it will be. So we saw here that it did the whole pipes thing. I assumed this was the middleware, but what I forgot is that the middleware is only applied when executing the job, not when dispatching it. So I'm actually curious. Where this gets set. Oh, in the bus fake, it seems is about where it's used. Interesting. That does mean that there is the potential for like outgoing job middleware. It's just not used. It's not. It's not really. I mean, it's exposed, but it's not really something that we really think about. I'm actually really interested in that because I think there is a world in which outgoing job middleware makes sense. An example of this would be adding the user to every job before it's dispatched. Adding some sort of metadata around the context. Maybe that is, a tenant ID or something like that before it gets dispatched. Currently, the way that you have to handle that is in the constructor. Like, it doesn't have to be passed in. You can maybe figure it out before that, but you do have to set all that data. And I think I really like middleware as an idea for sort of decorating objects that are transiting, sort of not through a pipeline, but ultimately through like a series of pipes, right? Whether that's an HTTP request that's coming through the HTTP stack, and then your router and your controller, or and then back out again as a response, or a job that is coming from your code and being dispatched into a queue, which then ultimately gets like sent over to a worker and then pulled back off that queue, right? I like the idea of middleware for those kind of networky type transactions. So yeah, I am curious about that. I think that it would be possible using pipe through to add that kind of middleware. So the way that regular job middleware gets kind of pulled into things. So if we go back to our, wherever the heck we were. Here. Is you define a middleware method on the job. And that is where like this pipeline is fed. And it defaults to an empty array, right? So what would be interesting is if there were two middleware functions. One that returned outbound middleware, and one that returned inbound middleware. For want of a better word, I don't really know a better way to say it, but yeah, I think that would be really cool. I do think that ultimately, not 100% certain that you can do inside out on the outbound, because if the end of that, like the inside of the onion, is dispatching it to the queue, anything you do on the outbound would not be useful in terms of the queue. But maybe you can add, timing metadata. So let's say you want to track how long it takes for your queuing. So the network latency of sending jobs over the wire. You could do that in an outbound middleware, just as an example. So yeah, I think it would be really cool if there was a function that did that. There isn't. So moving on. I'm not sure if that's something that you could build into like some sort of like replacement for something in the stack, like the dispatcher. That would be where it lives, I imagine. So if you were to override the dispatcher, you could ultimately override to call that function if it exists, right? So, all right, let's get back to this pipeline. So what I think is really curious here is, and this matters for all that I just said, is that at the end of the day, a async job ends up being executed by the exact same function that executes a sync job. Why does that matter? Well, because of what I just said in terms of that queue here, this pipeline, sorry, not queue, this would be executed here as well. And it shouldn't be. So, not if you want outbound to the queue and inbound being the current middleware. So something to also think about is that would cause problems. All right, so cool thing about that, though, is that everything we talked about dispatch now applies. The last thing we'll look at here is the resolve handler. So I believe this is where it determines which function inside. Oh no, this is the command handler. So this is where it's handled by, not the handle function. And ultimately it will go down to invoke or handle if you don't have those, which I'm sure most people don't. Here, okay. So that is, oh, wait a minute. Didn't we say that handler is always null? It is when you call dispatch. So this handler function, or method, argument, is used by the worker or async jobs. Find that interesting. Again, I find this code, while it is somewhat complex, is also quite elegant. And manages to distill a very complex thing, which is job execution, asynchronously and synchronously, ultimately down to just synchronously with queues in the middle. So pretty cool. Alright, so we've now seen the middleware in action. We've now seen how they get dispatched. We've seen how they come in and are parsed. What we haven't looked at is things like retries, for example. We sort of did. If we go back to our dispatcher, I want to go back to that. We'll just start here and just dig in. What I'm looking to get to is the serialization piece where it creates the payload. Okay, here. Nope, here. Here. Okay. Essentially, what happens is when you call fail, it will bump up max execution exceptions, I believe. Whenever you do a retry, it will bump up the retries key, which is not here, I'll note. Those things must get added after the fact. Let's just see if retries is in here. Now, let's take a look at... actually, I think it's part of the job, right? We look at inherited. Fail. Retries, I think, is part of the job. This would be part of the Reddish job. Why can't I find retries? Alright, we're just going to search the entire queue. Tries, maybe? Yeah, here. Get job tries. What is job? It's a mixed. I would have expected it in here. Going back to our test job. Is there a property called tries? I don't see one. Attempts. Okay. So attempts must have been in. Maybe I just missed it. Here. No, it's not in there. So it must get added. Again, it doesn't have to be part of this sort of envelope, because some queues will track that through headers and things like that, right? So the reason this attempts might be inside of the decoded object is because it's Redis, and Redis does not support that. Let's take a look at another one. Let's take a look at database jobs. Number of times, yeah, this is just going to be on the job model, right? I am going to take a look at something like a SQS job. Yeah, so these, I believe that these are part of the surrounding SQS envelope, if not part of the headers. So different for every job type. Okay. I did say that I wanted to look at the closure stuff. And then I think we're going to have to get into bus, which means like chainable jobs and things like that at a later date. But I think we've gone through the queue and jobs pretty well. Let's take a look then at the was inside of dispatcher here. Where was that? Here. Okay, yes, really curious about this because I genuinely don't know how it works. So, called queue closure create, so this is just a static constructor. New serializable closure, so it creates an instance of itself. And what is this? How does it work? Okay. So it allows signing, which is pretty cool considering we're sending this in a job queue kind of thing. Let's take a look at the unsigned one because I feel like that's going to be simpler. So it's using here. It's using reflection to get the code. Oh my. So it's actually reconstructing the code of the closure and just sending that over, and I suspect it's then, like with the scope and everything, then presumably it evals it. I don't really know how else it could work. Where is this package from? Taylor. Well, let's go. Look here. I apologize for My eyes, my allergies are going crazy today. Okay. That is interesting. Oh, that's interesting as well. So you couldn't serialize an object or a closure that had a reference to, say, a bag from my project, my value object project. That is frustrating. You'd have to turn it into an array, I guess. I was hoping for a little more here. Let's go take a look at this. How does it work? How does that work? I'd love to know how the eval is not used here. But that's not the point of the stream. Sorry, I definitely went on a side quest here. Yeah, that's long and short of it, is using this package. And who knows? I mean, it's going to be in here. Does it write it to disk? Or to a stream? That's what it is. That's actually pretty neat. So it creates a custom stream. Now, what that's backed by is kind of interesting. Yeah, it's essentially an in-memory stream. We can see the content is here. That's what it's doing. That is actually pretty neat. And a terrible... The fact that you can do that to get around, say, a block on the eval function? Interesting. There's definitely some security implications some people would have to consider there. I do believe that you can set which stream handlers are allowed in the PHP INI. I'm pretty sure that's a thing. I forget where these docs are now. The list of options. Here we go. There isn't an option. Interesting. It might be in the Yeah, that's an interesting implication. My main concern actually there was not the security implication. It was that someone could disable, by setting that setting, could disable this from working. And boy, would that be difficult to debug. I mean, maybe not. Maybe there's a very nice error, but I felt like that would be fantastic. All right. I think that is about where we're going to leave it. Appreciate y'all for hanging around a bit longer to get a late start and for putting up with the shenanigans on the stream today. Sorry it's been so busy. Y'all have any questions, reach out. Otherwise, I will be back next week at the correct time. Yeah, appreciate it. I'm going to go on stream ending soon, but I'll keep an eye on the chat for a few minutes, and if anything interesting comes up, I will come back to the stream. So I guess we'll do that one. Alrighty, so no questions, but just spend a little time kind of thinking about what I want to do about bus. I do want to cover bus, so I think what I'm going to do is next week's episode I will cover bus, and because it sort of came up and it's a little tangential, I'm going to cover how the fakes work. I mean, it's just sort of service container magic, but they are pretty neat. So I'll just add that in as a bonus. Yeah, I've definitely used them before, particularly when implementing my own facades. So, yeah, fakes are cool. That is it. Thank you all again for your time. Appreciate it. And see you next week, 10 a.m. Pacific.